Okay, our topic is algorithm design and problem solving. So, in order to design a computer system that performs a specific task or solves a given problem, the problem has to be previously defined and set up. So here we will see how we design a solution and to work associated with computer hardware to form a computer system. Definitely writing code in your own language and designing a solution in your own way needs practice to actually implement the code on a programming language. In the programming language, we will be definitely working on VB.NET. This is the language that we'll be working on. 2017 version, sorry, VB.NET. Now, the first thing is that we need to understand is what is computational thinking skills. This is a skill that is used to study a problem and formulate an effective solution that can be provided using a computer. If I could just write down this, like um, computational thinking is used to study and uh, computational thinking is used to study and formulate an effective solution that can be provided using a computer. So actually, we are the one who solve the problem, who design the solution of a problem, and then using computer we try to implement that solution. Now, the first step in our computational thinking is to do some abstraction. The first step in computational thinking is abstraction. Do you have any idea what is an abstraction? Anybody from fine arts or somebody did in fine arts in O levels? नहीं आइडिया. एब्स्ट्रैक्ट का तो होगा ना पता. एब्स्ट्रैक्ट का मतलब it means extracting something relevant only and missing out irrelevant information. So abstraction is uh, the process of extracting information that is essential while ignoring what is not relevant for the provision of a solution. So you can explain it in many ways. For simplicity, I could say that uh, when an when an artist do some abstract work, so what the artist do, that person emphasizes more on the part of its artwork which is relevant to its idea, and just leaves out other information which is not relevant to the abstract art part. So this is we have to do when we are working. Now for computer science, I can give you a very simple information, a simple example. For example, that if I am creating a database of my contact list, in that context list, what information is relevant, I'll be collecting that. I'll be collecting the contact name, contact number, maybe email address. That's it. That person whose contact I'm collecting uh, might have many more, definitely will have many more information relevant to that person, like date of birth, like uh, current address, gender, place of birth, company of working, father's name, mother's name, national ID card number, passport number. So there will be many, many, many pieces of information which are relevant to that this object. But in relevance to my contact list, I might need only three pieces of information. So I have extracted. I would only extract that part. So in the same way, when we are looking into a problem in computer science, we do what? We very carefully observe that problem, and we look into that what data we require for the solution of this problem. This is abstraction. So if I could just simply write a definition, abstraction is uh, the process of extracting information that is essential while ignoring what is not relevant for the provision of a solution. Okay. So this is the description of abstraction. Then we have uh, the other point, which is decomposition. Number two, D, sorry, decomposition. Decomposition means simple, breaking down, uh, breaking down your problem into smaller parts. Because solving smaller parts uh, is a lot easier than solving the whole problem in one go. So this is the simple definition of decomposition and explanation. So what will we will be doing, that we will be dividing our the whole problem into smaller parts. As I just mentioned, that solving smaller parts, solving a smaller part is lot easier than solving the whole bigger problem in one go. So the decomposition is the process of breaking a complex complex problem into smaller parts. This is known as decomposition. And then the last thing is algorithm, which actually we have to work on. So these first two definitions you can just memorize, and it's good if you understand. So just read a little about these two things. Uh, the first one was abstraction, the second thing was decomposition, and the third thing is algorithm. So algorithm means actually the design, the solution, the steps that you have given in some kind of an order, and you will drive the solution, you will drive the algorithm after doing this abstraction and decomposition. Unless you haven't studied your problem very well and you haven't divided your problem into smaller parts, the complex problem into smaller parts, your solution will not be perfect, and your algorithms will not be perfect. So if you have done abstraction and decomposition, so your algorithms, in other words, your design, in other words, your solution will be one of that which will be uh, efficient one. If I just write a simple definition about algorithm, I would write an ordered set of steps to be followed in the composition, sorry, in the completion of a task. So this is what algorithm is, and this last two things, inshallah, in the next class we'll do these steps, or we'll look into some problems, and then we'll work on these things that I'm mentioning. So we can write our algorithms in one of these three ways. One is structured, one is structured English, and that means writing your logical steps in algorithm using an agreed subset of straightforward English words. Uh, means these steps together with the order are called an algorithm, and all those mathematical solutions will also be in simple English. So you can say structured English is a method of showing your logical steps um, using an agreed subset of straightforward English words. Means there will be no mathematical solution. It will be simple, straightforward English instructions. Definitely structured English structures like open, file, input, data, output, and likewise. So simple structured English. There is no mathematical or logical explanation. And then there is a method of flow algorithms that is known as flowchart. Flowcharts are diagrams in which algorithm is shown as diagrammatically using using a set of symbols linked together with flow lines. For example, I could just say like this: start, and then some inputs, and then some processing, and then maybe some if conditions, and then some processing again, and then maybe another if condition, and then maybe uh, going back as a loop, and then uh, maybe showing some output, and then end. So these are the symbols that normally are used. This symbol is used for input and output. The symbol rectangle is used for processing. This is used for any condition. Normally we say if condition. Another word that I'm going to use in the next lesson is selection. And here we are showing some kind of a loop. Sometimes we do insert the loop symbol also, और उसमें हम ऐसे loop लिख भी देते हैं. And we always show a start and an end with a such symbol. So these are our three methods of writing our structured English language code. Do you have any question, Bacha?
Sir,